Welcome to this explainer. Look, if you're a cloud architect managing an SAP Business Technology Platform landscape, I don't need to explain the universal pain of manual configuration to you. You already know it. The endless clicking, the repetitive tasks, it's just tedious, right? Well, today we are exploring the promise of true automation, so we can leave all that manual drudgery behind for good. Let's dive right into the transformation from clicks to code using Terraform. Here's our game plan. We're going to start with the shift from clicks to code, check out the SAP provider ecosystem, walk through the four-step workflow, talk about managing state and dependencies, and finally, wrap up by conquering brownfield setups with the exporter. All right, part one, from clicks to code and the pain of the status quo. Think back for a second to the bad old days of what we call ClickOps. You know the drill. You're relying on static Word docs, endless Jira tickets, and dusty wikis just to click sequentially through the BTP Cockpit. It's incredibly error-prone, and you literally have to repeat the whole shebang every time a new project spins up. But when we switch to infrastructure as code, everything changes. Execution happens in parallel. Your configurations are securely versioned in GitHub, making every single rollout perfectly repeatable and consistent across your entire landscape.
So just to make sure we're totally on the same page, what actually is infrastructure as code? Well, it's exactly what it sounds like. It's the process of writing out your infrastructure requirements as machine-readable code rather than interactively clicking through a UI. You simply define what you need, and the code handles all the heavy lifting of provisioning and management.
Moving right along to Section 2, the SAP Provider Ecosystem, a provider for every need.
You might be wondering, why use Terraform specifically? Well, to put it simply, it boasts over 3,000 providers in its registry for various hyperscalers and platforms. It is the de facto industry standard, no question. By tapping into Terraform, SAP is letting you rely on a massive, battle-tested ecosystem to automate your landscape.
And SAP's specific approach here is actually really smart. It relies on a brilliant separation of concerns. You don't just get one massive, tangled, confusing provider. Instead, they break it down. You've got the SAP BTP provider for managing your subaccounts and entitlements. Then there's a dedicated Cloud Foundry provider for app lifecycles, a Cloud Identity Service provider for users, and even a Cloud Connector provider. It's like a giant puzzle where you get to mix and match the exact pieces you need for a complete end-to-end automated configuration.
Which brings us to Section 3, the four-step workflow. Let's look at this magic operational rhythm.
Once you start using this, there are 4 simple steps you are going to use every single time. First is init. This initializes your script and downloads the necessary plugins, like that SAP BTP provider we just talked about. Second is plan. This is absolutely crucial. It's your safety net. It gives you a preview of the exact delta, or the changes Terraform is about to make. Third is apply. This is where the actual execution happens and your infrastructure springs to life. And fourth, the incredibly powerful destroy step. This rolls back and perfectly cleans up all your resources, making it the ultimate cleanup crew for when you're done testing a proof of concept.
I love this quote because it captures the declarative nature of Terraform perfectly. Describe what you want, and you don't need to worry about how it is created. Think of it exactly like placing a restaurant order. You just ask the waiter for the specific meal you want. You definitely don't march into the kitchen and tell the chef exactly what order to chop the carrots and when to turn on the stove, right? Terraform is your chef. You give it the order, and it does the cooking.
All right, on to Section 4, managing state and dependencies and building the dependency tree.
So, Terraform loves efficiency. By default, it wants to save time by creating resources in parallel. However, it's smart enough to intelligently map out a dependency tree. For example, if your script asks for a brand new subaccount and then also asks to assign entitlements to that exact subaccount, well, Terraform automatically knows it has to wait for the subaccount creation to finish successfully before it even attempts to add those entitlements. It essentially guarantees your infrastructure builds in the correct logical sequence.
Okay, please pay very close attention to this next part because it is a massive best practice warning. Terraform remembers everything it builds in a central source of truth, which is called the state file. Because this file contains a complete, literal snapshot of your infrastructure, which very often includes highly sensitive configuration data, it absolutely must be kept in a secure, remote backend storage vault. We're talking AWS S3 or HashiCorp Vault. Under no circumstances should you ever just leave this sitting on your local hard drive.
But right about now, you're probably thinking, okay, this sounds great for a greenfield project, but what if I already have 50 existing subaccounts? It's the giant elephant in the room, isn't it? What happens when you aren't starting from scratch, but you have a messy, legacy setup that you desperately want to bring under code management?
And that leads us perfectly into our final section. Section 5, Conquering Brownfield with Exporter. Let's bridge that legacy gap.
Normally, bringing existing, unmanaged resources into Terraform requires a manual import. And let me tell you, that means you have to manually fetch the ID for your subaccount, manually write an import block, fetch the ID for your Cloud Foundry instance, on and on. It is incredibly tedious, sequential, and highly error-prone. Contrast that with the Terraform Exporter for BTP. This is a dedicated open-source CLI tool that simply looks at your existing subaccount, automatically generates the code blueprints, and even maps out the dependencies for you. It's a total game changer.
But let's keep it real and go over the actual realities of the Terraform Exporter. It's a fantastic open-source solution under the Apache license, and it wraps Terraform's native import function to do the heavy lifting of generating your script blueprints. But, and this is a really important takeaway, it is not a 100% out-of-the-box magic wand. It generates the base code, which means it still requires an expert administrator to step in, refine the HashiCorp configuration language, pull hard-coded values out into reusable variables, and really polish up that final script. And if you are going down this road of importing existing setups, please follow this critical architectural best practice. Never import your entire global account into a single state file. If you make a monolithic state file, you're going to suffer from massive loading times every time you run a plan. Even worse, if it gets corrupted, your entire landscape is suddenly in jeopardy. Always map one subaccount to one state file. This severely limits your blast radius if something goes wrong. Once you have your scripts polished, you unlock the CI/CD future. Because Terraform is essentially just a small binary, it can run anywhere. It plugs effortlessly into your existing pipelines, whether you're using GitHub Actions, Jenkins, or Azure DevOps. It securely unifies exactly how you roll out changes to dev, test, and production, ensuring they are identical and predictable every single time. So I'll leave you with this final provocative thought. Take a really hard look at your current SAP setup today. Is your infrastructure fragile, highly manual, and documented in some dusty wiki page that no one has updated in 6 months? Or is it alive, secure, easily repeatable, and safely versioned in your code? Thank you so much for joining me for this explainer, and I truly hope this sparks your own journey from clicks to code.